So my name is Suraj Vyas. I'm here to talk to you guys about water resources management and policy. Before I begin, I want to give a special thank you to some very special people. I want to thank Dr. Holland and Dr. Blaney, who are my faculty mentors throughout this entire process. I want to thank Ms. Carrie Souter, who is my INDS advisor. And I also want to thank Mr. Bradley Smith and Mr. Satish Kadiyala, who provided tons of insight on the wastewater treatment process. So before I get into the meat of my presentation, I was wondering how much you guys actually know about clean water. So how many gallons of water do you think it takes to make just 1 gallon of orange juice? Anyone in the audience, please shout out a number.
Starting with growing the oranges?
Sure, include that.
40.
40? It's actually around 53. That's pretty close. Let's try another. How about tea? 1 gallon of tea. What do you guys think?
20.
20? 130. 108 for you coffee drinkers. One last one. 1 ton of steel. What do you guys think? Steel's everywhere. How about 62,000? 1 ton. So that's a lot of water we're using in the world right now. How much water do we actually have? Well, 96.5% of water is actually salt water, and we don't currently have the means to extract the water from the salt unless you use an extremely expensive process. So we're left with 3.4 to 3.5% water. Out of that, 1.7%, half of it, is actually stored in glaciers and permafrost, which makes it very difficult to extract. The remaining 1.7 is what we do have, which is groundwater, and that's about 4 times 10 to the 20th gallons. And that's a huge number. But let's take a look at this artist representation showing clean water, looking at the Earth. So the largest sphere above the Midwest is actually the amount of fresh water we have in the Earth right now. To the right of that, you can see the fresh water that we have stored in the ground, lakes, swamps, and rivers. Even more to the right, a tiny minuscule little bubble is how much we have in lakes and rivers. So at the rate we're currently using water, this is not sustainable. We're expected to reach 10 billion people in the next couple of decades. We can't keep going at this rate. So how do we solve this issue? These are some questions I looked at in my paper. First, what can watershed management programs of the United States and India learn from each other to lead to a cleaner watershed ecosystem? Basically, I want to determine how we can stop the impending clean water crisis through research, innovation, and global cooperation. Being an interdisciplinary studies major, I also want to see how an interdisciplinary approach is necessary to solve this problem. So these are the 4 disciplines or fields I chose in my study. I looked at environmental science, engineering, management, and law. The major concept I looked at is wastewater treatment plants and how they get rid of contamination in the water. I looked at each field specifically and determined what they thought of the specific concept. So in terms of environmental science and engineering, I looked at how that relates to wastewater treatment. In terms of management, I wanted to look at the efficiency and effectiveness of the wastewater treatment plants. In terms of law, I wanted to look at how policies impact the actual wastewater treatment plants and what that means to them. So for major theories, I looked at the dominant theory in each of these fields and looked at how that would apply towards each discipline. In terms of environmental science, what I found was that they wanted to resolve the issue by allowing the watershed to rejuvenate itself through restoring itself. For engineers, what I saw was a trend towards fixing the problem using our resources and our technologies in order to rectify the situation. For management, it was more of throwing the money at the problem in terms of looking at things from an efficient and effective standpoint. And as for law, they used a means to regulate the watershed and policy their way to success. So at the core of interdisciplinary studies are bridging strategies. These are strategies that we use to bring together disciplines in order to extrapolate a greater meaning. Using the bridging the explanation action gap strategy, I combined the idea of environmental science and law in order to say that environmental science basically describes the problem, whereas law is using its disciplines and its strategy in order to implement the optimal solution to the problem. Using the strategy known as building complex and multi-causal explanations, I use that to connect engineering and management together. Basically, engineering and management challenge each other's findings and views, and what I found was that management may find a solution that is effective in theory. However, when applied in a real-life scenario, engineering has found that it may not work. So management and engineering need to tinker together in order to find an optimal solution to this problem. Next, advancing through checks and balances. What I did there was I combined law and management as well as environmental science and engineering so that the disciplines made checks on each other, saying that management must find an effective solution, but it must remain within the confines of the law and the policies that are being regulated. So how did I go about doing this? Well, here's my methodology. First thing I did was I chose a point source pollution. Point source pollution is exactly what it sounds like. It's a source of pollution coming from a specific point, such as a drainage pipe. The opposite would be a non-point source pollution, which is coming from a general area, such as pesticide runoff from a farmland. The reason I chose point source pollution rather than non-point source is because point source pollution is actually easier to manage and easier to see the effects of it directly into the watershed. Next, I had to choose 2 watersheds to do my study in. So I wanted to choose places that actually affected me. The first one I chose was the Chesapeake Bay. It's right in our backyard. I'm sure many of you are familiar with it. The next one I chose was the Ganga River watershed. That's located in India. I go to India every summer. I'm very familiar with the country. I'm very familiar with their culture. I'm also Hindu, and the Ganga River is a very important river in Hinduism. So that was special to me. Next, I had to learn about how a wastewater treatment plant actually worked. So what I did there was, again, thank you to Mr. Bradley Smith and Mr. Satish Karyala. They walked me through the process of how a wastewater treatment plant works, from disinfection to bioreactors to you name it. Next, I had to learn about the 2 watersheds in detail. So the Chesapeake Bay is about 64,000 square miles, and it cuts through 6 different states. The Ganga River watershed is 420,000 square miles, and that cuts through 4 countries. I had to take these into account when I was looking at the data I was going to collect next, which is from the wastewater treatment plants. I looked at 2 plants, the Patapsco plant and the Keshapur plant. Patapsco is located right around here, and the Keshapur plant is actually located on the outskirts of Delhi, India. And what I did there was I looked at their levels of BOD, which is, we can consider it as fecal matter in this case. I also looked at their levels of suspended solids as well as nutrient levels, phosphorus, nitrogen, carbon. And what I found was that the efficiency levels for the 2 plants were actually very similar. They were in the high 90th percentile. And so I thought to myself, well, that seems a little odd. So what's going on here, and why is there such a big pollution problem in these 2 watersheds? And so taking a step back, I noticed that there was actually a study done by the New York Times in which they looked at thousands and thousands of wastewater treatment plants in America. And what they found was that many violated regulations set forth by the EPA, but they didn't receive any fines. And I thought that was kind of weird. So I looked into that, and what I found was that the EPA actually didn't have the means to properly carry out their regulations and policy, their proposals. What I found in India was that the sewage lines were not actually properly implemented, and lots of people didn't have access to the sanitation lines. And so if people did defecate, they would defecate directly into the stream, and there wouldn't really be a chance to cleanse it afterwards. And that was a major problem. So what I found out is I actually had to redefine my entire concept of water management. I had to think of it as, rather than managing water, how can we manage people more efficiently? So these are some top ideas from experts. As for the Chesapeake Bay in America, what I found was that there's currently a plan going on where each state's going to submit their optimization plan, and that's currently not ready. It will be ready within the following year, so I don't have the data for that. However, in India, after doing research, what I found is the best solution, in my opinion, was the use of algae. Now, this is interesting because the Chesapeake Bay actually has an algal bloom problem, where basically there's tons of algae in the Chesapeake Bay, and it's using up all the oxygen, leading to a decrease in biodiversity, because the plants and animals that are in the bay don't have access to that oxygen anymore. But as long as this is monitored effectively in the Ganga River watershed, this is a perfectly reasonable solution, and there's no reason why it couldn't be implemented. So in conclusion, this is what I learned from the process. Both countries are actually doing what they think is right to rectify the situation, and both can learn from each other. The USA needs to learn how to properly manage its funds as opposed to India, because India is actually understands that its problem is in distribution and sewage lines rather than building up new plants. America is currently building tons of plants. Like the Blue Plains plant in DC right now is the most expensive plant and the biggest wastewater plant in the world. Rather than managing the money in that sense, maybe they could have tried looking at it from the stance of understanding how other plants may have done a better job, regulating the plants we already had in place rather than building a new one. As for India, I found that India needs to use the powerful force of law as a tool to actually move people towards these sewage lines and understand that these people may have the technology, but they need to be educated on how to use it and where they can go to use it. Another thing that I found was that this larger flow that may come from the Indians learning about the sewage plants properly needs to be properly mandated, and the plants need to be ready to keep up the same efficiency levels as they have right now in the high 90th percentile. So how do we counter this crisis? Once again, it comes down to research, innovation, and global cooperation. We need to all work together if we're going to solve this problem, and the only way we can do it is together. So this is what I want you guys to take away. I learned a ton from this project, but all I want you guys to take away is this. The clean water crisis is real. We need to save water. It's a really important commodity in our lives now. Money isn't always the solution, and I want you guys to take an interdisciplinary perspective on everything you look at, from literature to numbers to statistics to everything. I would have never thought about the idea of managing people rather than water had I not taken this interdisciplinary perspective on the subject. Also, I want you all to be open to different ideas, but also question them. Don't take anything for granted. Don't take anything at face value. Again, I want to thank all these people for their amazing hard work, love, and support through this entire process. And I want to thank all of you for coming out today. If you have any questions, please let me know.
Thank you. You have plenty of time for questions.
Good.
So you talked about sort of what the experts say should be done.
Right.
What is happening? I mean, what are folks? Obviously, we're more aware of the issues that are going on with the bay. We've got nutrient overload. We've got these dead zones and that sort of thing. So what are we doing here, and what can you say about sort of what actually is happening in the Ganga?
Okay, so in terms of America, what we're currently doing is, a lot of it is actually awareness. So I don't know if you remember, for a while they had the whole Save the Bay idea, and that was going strong for a long time. It's still around, though not in as much strength. But the main thing is raising awareness and just getting your politicians to know what's going on. Another thing they're looking at is America's actually trying to build new plants, which in my research I found that may not have been the best solution, rather than just finding better ways to regulate the current plants. Like the EPA didn't have enough funds to actually go out and policy the other plants, so I think that may have been a better solution. But that's what they're currently looking at. As for the Ganga River, right now the Indian government is actually not giving tons of money to water management, but they understand it's a problem and they know sanitation lines need to be implemented. It's just, I think they're still figuring out how exactly to go about doing this, because people in rural areas may not have easy access. Like, we can't get a toilet in everyone's home there. A public toilet area would certainly be feasible. It's just about educating people on using it. Any other questions? Sure.
So if I was just to play devil's advocate and say that through awareness in Chesapeake, you can tell me that I can understand why it would be good for me to reduce water, but how are we going to, is there anything more than just my awareness and my sense that that would be a good thing to do, that is going to lead me and everyone in this room to reducing our water intake?
In the sense that I can't control any of your actions, of course. I can only educate you and hope that you do what is right for the whole planet. But honestly, no one can really do anything other than raise awareness. It's up to each of us individually to really take action.
Question. In terms of this algal solution,
Sure.
I wasn't clear. Is that a process that you would want to implement within a wastewater treatment plant, or is that something that would be more within the river itself?
Yeah. So the algal idea was actually, it's going to be implemented in the river itself, in portions of the river, in the Ganga River. It's not something that they're looking at in the wastewater treatment plants. However, that was the best solution I found when looking at the Ganga River ideas.
So it's kind of interesting to kind of say we have this point source problem, but then you're kind of approaching the solution from a
non-point source way.
Approach.
Right. So since I found the efficiency levels were so high, like in the 90th percentile, I realized that maybe that's not the issue, and that's why I had to transition into the managing people idea. And so I had to look at it from a non-point view, even though I chose to look at it from a point view in the
And then in
beginning.
terms of maintaining that algal community, how do you do that in the river?
You have to monitor the algal growth, I think, over time, and you have to make sure it doesn't get out of hand. And the only way to do that is kind of to look at different studies, contained studies in which they might take a certain amount of algae and then realize, okay, this is too much, they're consuming too much of the oxygen, and so plants and animals are dying. And based on those numbers, they're gonna have to apply it to the real life scenarios. And honestly, you have to hope it plays out, because you don't always know if it's gonna work.
So, good job on the presentation.
Thank you.
You said ultimately it's up to each of us individually as to
Right.
how we use water. And if that's the case, how do you manage people? And in your research, did you see any effective management models or campaigns that had an effect on usage?
So I think the best way to manage people is actually using the law and implementing policies that'll make people want to change. Because I don't think the majority of people in the world right now really understand there is a water crisis, even though there is. And I think the only way to really tell some of the people is to have strict policies and laws in place that make people want to change.
And have you seen any successful models in that area, new policies that are actually making?
So I've seen both tax breaks for water usage, as well as there's the privatization of water in certain countries and even cities in America. Like Atlanta actually has privatized water, where you have to pay it depending on the amount of water used to a private company, and they can adjust the price accordingly.
Mm-hmm.
So that's kind of a good motivating factor, I think, for saving water.
Thank you.
No problem. Sure.
I'm interested in what research you might have had about the animal issue. I know we've done a lot in the United States to try to educate farmers and keep their animals away from streambreds. You said you were Hindu. How is that handled in India?
It's not handled very well in India, to be quite honest. So if you're going to talk about India, I think the big source would actually be from cows, and they're very symbolic and religious, so you can't really, it's not proper to control them in that environment, really. So no, it would be proper. They can easily put fences and things up, but it's just not being done at the moment.
So law would not be appropriate there?
The law might be a little tricky there. It would be hard to get it passed, I think.
Well, thank you. That was right on time, so much appreciated.
Thank you.